Let's move on to the last part of topology. Lastly, in topology, we have Cutset Matrix, minimal set of branches of connected graph such that removing these branches, the graph would be cut into exactly two parts. If we replace any branch of the cut set back, the graph becomes connected. An important thing here to keep in mind is cut set equals to one branch of the tree plus links, okay, and the network is divided into two parts, okay. This is what we are going for, okay. Fundamental cut set equals to connected graph, and the twigs and links are subtracted from that, okay. That combination of twig and link that divides the graph into two parts is called the cut set or fundamental cut set, okay. For n number of nodes, twigs equals to n minus 1 and number of twigs equals to fundamental cut set, okay. So this is also n minus 1. Now we will be seeing this through an example, okay. Suppose we have the original graph over here, okay. We are marking the tree, okay. This is our tree of the graph, okay, with twigs as D, E and F. You know the branch of a tree is called a twig, okay. You can go to part 1 if you don't understand the concept of tree, twigs, links or etc, okay. Now what we are going to do, we are marking the code tree, okay, and links as well. See, this is the code tree and these are the links. A, C and B are the links, okay. Number of twigs equals to fundamental cut set, okay. Here you can see that we have three twigs, twig number 1, twig number 2 and twig number 3. So those will be the number of cut set as well, okay. This is one twig, so this will be cut set number 1. This is the second twig, this will be cut set number 2, and this is the third twig, so this will be cut set number 3. Now what we are going to do, we are going to write cut sets 1, 2 and 3 in this particular fashion, and then we are writing the number of links A, B, C. Here you can see A, B and C are the links. These are the dotted lines, so you write them as this, and then you write the twigs. The branches of the tree are called twigs, okay. D, E and F are the twigs, okay. Now what we are going to do is we are taking one cut set at a time, and then we are assigning values as per, like, if you are having means, first of all we are taking all the branches that are not at all connected to that cut set, okay. Here you see in cut set number 1 only B, D and A are connected, the rest will be assigned 0. F, C and E will be assigned 0. F, C and E are assigned 0. Same goes for cut set number 2. You can see that only B, E and C are connected, okay. D, F and A are not connected, so D, F and A will be assigned 0. You see D, F and A, D and F are assigned 0, okay. We are going to follow this for all the cut sets. Then what we are going to do is we are taking one cut set at a time again, and we are assigning values to the branches that are connected, okay. If it is moving away from the cut set, we are assigning +1. If it is moving towards the cut set, we are assigning -1. Here you see for cut set number 1, branch B and D are moving away, so they will be assigned +1. B and D will be assigned +1. Now A is moving towards cut set, so this will be an assigned value as -1, okay. See, A is assigned -1. Now we will move to cut set number 2, okay. Here you see that E is moving away, so this will be assigned +1, okay. E will be assigned +1, and you see that B and C are moving towards, so they will be assigned -1. B and C, you see B and C. We will follow this process for all the cut sets, okay, and the matrix hence obtained is the cut set matrix, okay. Now let's talk about cut set and KCL. It is given by this formula, okay. QIB equals to 0, okay, and the format of this formula is QIB equals to 0, okay. You can find the branch currents through this formula, and then we have branch voltage and fundamental cut set voltage, okay. We have this formula, okay. We are using KVL, and the format of this formula is as follows, okay. This is all the cut set voltages, the matrix and so forth, okay. Now what we are going to do is we have studied that set of twig and links that makes a graph half, okay. So we are taking an example through this diagram, okay. This is the original graph that we are having, okay. You see that we are having 4 twigs over here, okay. This is the tree, and these are the 4 twigs of that graph. Now what we are going to do, since we are having 4 twigs, then 4 will be the number of cut set as well. Now we are taking one cut set at a time. Okay, now what we are trying to do is we are taking that one twig and number of links that will make this graph in half. Okay, we are concerned with C1. Okay, so the cut set will be this twig and these two links. Okay, if you subtract this, the graph has become half. Okay, same goes for cut 2. If you take this twig and these two links, okay, then this graph has become half. Same goes for this, we are taking this twig and these two links and this graph has become half. So this is what we are going for. Okay, let's see cut set number 1. Okay, the twig is twig number 4 and the link here is link number 1 and 6. The cut set matrix you will have is 1, 4 and 6. 1, 4 and 6. Okay, you remove these, you get half of the graph. Okay, now let's move on to cut set number 2. Okay, here you have twig number 7 and link is 6 and 8. Okay, 6, 7, 8. If you remove these, you will get half of the graph. Okay, so for C2 it will be 6, 7, 8. For C3 this will be 3, 5 and 8. 3, 5 and 8. And for C4 this will be 1, 3 and 2. 1, 3 and 2. So this is all for fundamental cut set twig plus link. Okay, this is all for network topology. This is the entire sheet and this entire sheet has been completed.